Welcome to my YouTube channel. My name is Dr. Emmanuel Nweze, a lecturer at Alex Ekweme Federal University in Dufalike, Nigeria. We want to look at Introduction to Numerical Analysis, NT 228, using Jupyter Notebook. Our first lecture is on bisection method. Bisection method is a technique we use in tracking the root of a nonlinear function which lies between two given points. Our basic assumption here is that you already know the basic algorithm behind this method, and our aim here is to show you how this is done using the Jupyter Notebook. The first step is to import the module that will help us calculate this. Look at it clearly and see where we have written import numpy as np. This will help us do the calculations, and then we define the function f of x. In this case, our f of x is equal to x cubed minus 4x minus 9. Our intention is to find the root of f of x equal to 0 between a given interval. You now see again, the next line you see maximum iteration to be 200, that's by choice. And then we look at xst, that is the estimate of the roots. We'll create up to 200 positions for this estimate. So we expect to get about 200 estimates. After that line, you will see a equals to 2, b equals to, the interval is between 2 and 3. So we expect that the root of this function, f of x equal to 0, should lie between 2 and 3. Then we also create a number of iteration which should be in the range between 0 and the maximum iteration. And then we check the intermediate value property to see whether there is a root. And there we compute the product of f of a and f of b and store it in fv. Then we find out whether fv is less than 0. If fv is less than 0, then we are free to carry out our iteration. Otherwise, we have to terminate, concluding that there is no root. But in this case, there's a root. And then we have to proceed from the line where you see 4, I in item. That you want to proceed with the iteration now. And then using xs I, it will be the sum of the two endpoints a and b divided by 2 as the root estimate. If I equal to 0, that gives you the first estimate. If I equal to 1, that gives the second estimate, and so on and so forth. That you can print as shown in the next line. Then when 3 of the estimates are concurrently the same, then a point of convergence has been attained and we can terminate the iteration. Then we use the last point as our solution. Below you see where a and b are assuming other numbers. a1a, b1a plus b over 2. In this case, the interval has been divided into 2. The a to b has been divided into 2, giving rise to 2 different intervals. And each of them, a is assuming their extreme points. And we repeated the process continuously, checking whether f of v is greater than 0. And at the end, we got some solutions. The first estimate of the root x0 is 2.5. The second estimate is 2.75. continuing. We expected 200 iterations, but this could not hold, because at some point at point 51, at I equal to 51, 52 and 53, the estimate remained the same, and according to the imposed condition, we now see that the convergence has been attained and iteration terminated. So the final answer becomes 2.7065279 as the root of that function f of x equal to 0. Of course, you can see the value of the f of x, which is 7.105 times 10 raised to the power minus 15, very close to 0, showing that the method has successfully terminated. Just after that, we see the error bound. Usually, in every bisection method, the error bound is given by b minus a over 2 raised to the power n. Why do we use this? We use it if we want to find out the number of iterations we need when we have imposed existing criteria. Supposing we want the error bound to be 0.001, then equating this with b minus a over 2n and solving for n gives you the number of iterations. Thank you for watching this program. Bye.